What is science like at Charlestown?
It's fun, and you get to do all these like sort of experiments, and they just show what it's like.
What is your favourite part of science?
My favourite part is probably the experiments. My favourite part is like the experiments, but also knowing what's happening to it and writing all the stuff down.
Finding out all the good stuff, learning things. What are you learning in science right now?
Our new topic is about World War II. And the science we did for it was... Oh, we're learning about living habitats.
Ah, cool. What is a habitat?
It's where like an animal lives, or a human.
Yeah. What do we do for investigations at this school? How do we do them?
We do a question, prediction, and our conclusion, and equipment, method, results, and conclusion.
These are the shapes.
Yeah. Yes.
What about the shapes? Can you remember your most interesting investigation you've done so far?
I think my favourite was all the liquids that we done to the paper boats. My favourite was when we had some vinegar and I think it was baking soda, and we put the baking soda in, bicarbonate of soda in a balloon and tipped it upside down into the vinegar, and it expanded the balloon.
Cool, well done. That's cool stuff like that, isn't it? Might you want to be a scientist in the future? And if so, what type?
Yes, a chronotechnologist, which I found out finds the existence of diseases. Yeah, so like a medical scientist. Yeah, I want to be a medical scientist as well, because I think it's like you get to know what's happening and all that.
That's really helpful for the world and stuff, isn't it?
Yeah.
What is it like being a science ambassador?
It's fun because you get to prepare experiments. Yeah, it's fun and it's very interesting because you can see what is actually happening in that experiment, and you can also show it to your class that just say they haven't done it before. You can show them the experiment that you have done. Yeah.
You two in particular having a really big impact on all the children at the school, especially in year 1 and 2. Their teachers tell me how big of an impact you're having on them.
Yeah.
Do you do science at home? What do you do?
Yes, loads of it.
Loads.
Especially food related.
Food related is the best. And last one is, how can we help others to love science?
Maybe to encourage them to do more experiments that are fun and make the lessons more fun. So the teachers can make it more fun, and then that's how people can probably enjoy it more. And we can also make it better by if they don't understand it, we can make it simpler for them. And if they were really got into science, and maybe they could be like a science ambassador like us, or a scientist.
Or a scientist. Well then, anything extra you want to add?
Nah.
No. Cool.
Hello, so today I'm going to be doing absorbent. So all you need is a large bucket of water and a fruit. So I'm using lemons, and I got one peeled and I got one peeled. So first of all, I'm going to pop this lemon into the water and see if it sinks or floats. So it floats. And even if I do this, it still floats. So now I'm going to pop this peeled lemon into the water. So it's sunken down. And that's also because that I left it in the water for a few minutes so it could absorb more water, and then it will sink. So the longer you leave it in, the more deep it will sink. So the reason that this one is floating is because it's got skin around it. So the skin is waterproof and it protects it from all the water getting in, so it can't absorb anything. However, this one has no skin on it, so there are many holes inside so that the water cannot get in, and the lemon will start absorbing the water, then it'll get heavier and heavier and sink down. So that's how it works. You can also use a tangerine or a lime or an orange, something that you can peel like a lemon. So bye-bye.
Hello. Today I will be experimenting the force with a simple thought experiment called Newton's Cradle. This toy was named after Sir Isaac Newton. Today we will be investigating how the energy will travel through the balls. I think that these kind of materials might not work so well as they have less mass. The marbles, I don't know, but maybe they will. And the Mentos, well, that's just silly, isn't it? So, the materials you will need to be able to create this Newton's Cradle: you'll need jumbo lolly sticks, you'll need glue, it doesn't matter what you've got, you'll need a hot glue gun for gluing the materials onto the Newton's Cradle, you'll need a thick string, but not too thick that it's like wool, but not too thin, so when it tries to hold a marble or a Lego brick, it just snaps. You'll need a pencil, and you'll need scissors. You'll need some tape. And if you're trying to make a Newton's Cradle, any of these materials. Otherwise, you could experiment with your own materials. Maybe you'll find the best way to make a Newton's Cradle. So here is my complete model of the Newton's Cradle. Now, what happens is, look, the point is that this ball is going to carry the energy through the balls and into that one, so then it will hopefully hit up. Now let's see if this works. It did. And now let's see how it does with two. Wow. So as you can see, this Newton's Cradle will work. All I hope is that it doesn't take that long for a factory to actually make one. So, I found out that Lego bricks do not work. Now there could be two reasons why these Lego bricks don't work. One, because they have holes in them, so they might be very airy. Or two, because they're less dense. I was wondering, will it be the same with the bells? I found out with the bells that they make a nice jingle, but there's not really much action. I'm wondering if this proves that with the Lego bricks, the problem was that they're hollow inside. Problem is with these though, they're also pretty lightweight. But I think the hollow thing makes more sense because when I hit it, when it goes down, it kind of bounces. I don't know. But let's find out who will win, because next, I've got the Mentos. So, I found, in conclusion, the Mentos sort of worked. But the best thing that was made was probably the marbles. Thank you.
Today I'm going to teach you how to make water travel through to an empty glass without even touching it.
How many glasses do you need?
We need 7 glasses. Then
Which ones are you going to put water in?
I put water in this one, miss this one. This one, not this one. And this one, miss this one. Then this. So that's how much you need. And then you open a food coloring. And I'll use
Which colour have you got there?
I've got red here.
How many teaspoons?
I've got. You need about
That's it, hold it over the glass.
2
2 teaspoons, okay. And the end one as well, isn't it?
And then this I have to. Mommy, can you hold me?
Yeah. So 2 teaspoons, give it a good stir.
Then you have to
That's it, give it a good stir.
stir. You got a spoon. This one on the spoon, and then da-da-doo. Ah!
That's it, 2
Going
in that one. Give it a
crazy.
good stir.
And put it in a bowl. Now. And now I'm gonna put some yellow in. But your yellow might not look like this, so I've not got any yellows like that, so use this one.
Just wiping up that food colouring that you spilled a little of. Okay, so how much yellow?
Oh, need about
Hold it over the glass, sweetie.
need about 2 teaspoons.
That's it, and then pop it in the bowl.
Pop it in the bowl. And I'll put the lid back on.
Okay, now what do you need to do?
Now you have to get about 6 pieces of kitchen roll, and then you put this one in here. Make sure it's in the red, and then you have to carry on. Last one.
And then how long should we
And
leave
you
it
have
for?
to wait for 1 or 2. This is what it should look like after 1 or 2 hours. And as you can see, the water has travelled through the empty glasses, and it looks like a rainbow because the colours have mixed together.
And which colours have mixed?
So the yellow and red have mixed together to make orange, and the blue and yellow have mixed together to make green, and the red and the blue have mixed together to make purple, and they've mixed together to make a colour because they look quite similar to the colour that we were making.
So what does your experiment show?
It shows how water can travel and how to mix colours.